Hey everyone, I hope you guys are doing really well. So let's see today's daily challenge on Leetcode and we will try to solve it together. So I will show you multiple ways to solve this problem, and yeah, this is the kind of problem if you are thinking it in the right direction, you can solve it quite easily without much hassle. Otherwise there might be a little bit difficulty. Okay, so let's see the problem statement and what it wants to say to us. So number of ways to paint an n cross 3 grid. So you are given only three colors, okay, red, yellow or green, and you have a grid of size n cross 3 and only the n value is given. So in this example you can see the n value is 1, so you have a 1 cross 3 grid and you want to fill them with only three colors which are available to you, while making sure that no two adjacent cells have the same color, both horizontally and vertically. Okay, so given n number of rows, return the number of ways you can paint this grid. As the answer may go large, you must compute it modulo 1 plus 7. So if you try to see what it is trying to say to us is that you have a n cross 3 grid, okay, and you are, let's say, you are given three colors. Let's call it A, B, C, okay. And if you fill A here, you cannot fill A here. You can fill only B and C, only B and C over here. And if you filled B here, you can fill only A and C over here, and so on for all the cases, like both horizontally and vertically. You need to make sure that the cells are filled properly. So if you talk of this cell, so let's say if you filled an A over here and you can fill B or C over here, B or C over here. But if both of them are B, then you can fill C or A over here, right? Okay. If both of them are C, you can fill A and B over here. If both are different, like both are B and C, then only choice is to fill an A. Okay. So I hope you do get the problem statement, at least what it wants to say to us. And yeah. So one thing is very obvious, like if I want to tell you for n equals to 1 calculate the answer, what will you do? You will see that, hey, I have three grids, okay, and this is a 1 cross 3 grid. I have three choices to fill over here, okay, and let's say A, B and C. Whatever I filled here, I cannot fill here, so I have only two choices to fill over here, and again another two choices to fill over here. So I have a total of 3 into 2 into 2 number of cells. Okay, so that will give me a 12 total number of 12 choices for n equals to 1. So as you go with n equals to 2, you do realize that you can't just have a number for each cell and just multiply them. Okay, 3 into 2 into 2 you did for n equals to 1, but for as you go with n equals to 2, you will find that it depends on a lot of factors, like as I told you, if you place an A over here and B and C, then it depends what this cell, what you will fill in this cell, it depends what you filled in this and this cell also. Okay, so yeah, you can't just assign a number and multiply it always for n equals to 2 and further. Yeah, but you can try to think it of in this way. Let's say I have already computed n equals to 1, right? So I have the first row ready with me. Now I am going to fill the second row. Okay, so I am going to fill the second row, and using using these combinations which I have already filled of A, B and C, can you help me to fill this row? Okay, so let's see in how what all ways I could have filled the first row. Okay, so can you see that broadly there can be possible ways? Okay, so one thing is that what I could have done is, uh, let's say this is green and this is also green, and in between this, do you understand what I'm trying to say? This is a valid combination for a n equals to 1, right? So I could have filled it in this way. That is, although I have A, B, C three colors, I am using only two of the colors. I am using only two of the colors. Okay. Otherwise, I could have also done something like this. I hope you do get what I'm trying to say. I could have also used something like this. Just tells me that hey, I am using all of the three colors. Okay, all of the three colors I am using. Okay, so there can be in broad perspective, there can be two ways to fill. Okay, using a two color combination. Okay, and using a three color combination. Now let's calculate that for n equals to 1. What can be the possible ways to do that? So for n equals to 1, I just see what can be the ways. So let's say A, B, C. I am using all the three color combination. A, B, C can be there. Okay. Then A, C, B can be there, and so on. You can see how many can be there. There can be 6 ways, because in the first place you can fill 3 into 2 into 1. It's 3 factorial, right? It's just a permutation. So 6 ways are there. Considering all the three colors are different. Okay, all the three colors are different. Now you consider a 2 color combination. Now it's quite obvious that since this is not a valid combination, AAC, so if you are repeating a color, uh, see, this was a 2 color combination. Okay, this was a 3 color combination. Now I am talking of the 2 colors. So if you are repeating a color, they must be repeated on the extreme sides. ACA, this is a valid. Okay, this AAC, it is not valid. Okay, I hope you do get it what I'm trying to say. So we take care of that. ACA, what are the possible cases? You see, ABA. Okay, and how many ways will be there? So by default, you know, there are total of 12 ways. 6 ways you have used here, so you do not need to calculate. Actually, you can directly say there are 6 ways here also. So 6 ways are there for a 3 color combination. 6 ways are there for a 2 color combination also. Okay. Now what are all things which you can derive? Okay, so you see, let's talk of the 3 color combination first. Let's say you are having a combination like A, B, C. Okay, you are having this combination. What are all the ways you can get? So can you get this thing? Can you get this thing? Can you get a B? See, beneath A, this is your I minus 1 row. Okay, so let me be very clear. I am just trying to say that from the first row, how can you derive the second row? That is what we are all trying to figure it out, right? So in general, from the I minus 1th row, how can you fill the ith row? That we are trying to see. If the I minus 1 has a 3 color combination, how can you fill it? So you see, underneath this A, you can fill this B, you can fill this C also. Okay, you cannot fill A because underneath the A and A there will be repetition. So yeah, you can do it. And what can you do now? You can also fill a C over here. Okay, and you see, underneath this C, what are all the things you can fill? You can fill an A. Also, you can fill a B. Okay, so underneath the A, you have these two choices. Underneath the C, you have these two choices, and the middle one is a distinct choice. Can you have anything else apart from this? Can you just tell me whether any other 3 color combination? See, what I'm trying to derive is that from a 3 color combination. So basically, from this 3 color combination, I'm trying to see how many more 3 color combination can be there, which can be derived from I minus 1 to I. Okay, what are so these are only the 2 ways you will get. You can try to think of some other ways. Okay, so but you will not get any. So you see, beneath A you have B or C. Both of the cases I've taken care of. And yeah, if you are not going to repeat colors, that is the constraint here. So yeah, from 3 color you get 2 3 color combinations. Okay, now you try to see from a 3 color how many 2 color combinations you can get. Okay, so that can be an interesting one. So it's not much difficult. You see, this B only you have to repeat. See, for a 2 color combination, you know that the extreme sides, these two sides are repeated, right? So they have to be B only, because they cannot be A, they cannot be C. So what are the possible ways? B. So beneath this A, B, C, what you can also write is this something like this. Okay, so let me write the whole thing. Yeah, and I have this C and I have this A. I can only write this many 2 color combination. You see, if I place this BCB and BAB in beneath this ABC, so I will have this 2 color combination. Okay, so one 3 color combination gives you 2 3 color combinations and 2 2 color combination. Okay, so that is the lesson we get from here. Now we want to check that if I minus 1 has a 3 color combination, we can directly say we can have a 3 color, 2 3 color and 2 2 color in the next row. Okay, from that it can be derived, and recursively we can just say that, hey, and again these are 3 colors, these separately will generate again 2 3 color combinations, and that way we can go on till n. Okay, I hope you do get an idea of what I'm trying to do. So now let's take care of a 2 color combination. Okay, let's take the color to be A B A. Okay, so that's what we will do, A B A. So can you tell me how many 3 color combination you can produce from here? From I minus 1 to I cell, how many 3 color combination can you produce? Uh, you will find underneath this A, if you try to write C, if you try to write B, okay, and again underneath this A, if you try to write, since the colors must be different, I'm trying to produce a 3 color from 2 color. Okay, so B and C, and the middle one to be A. Okay, these are both the valid colors. So you see, from these only these two ways you can fill. So, okay, so you can try to think of some other ways of how you can generate a 3 color combination from this 2 color. Only these 2 ways will be there. Okay, I hope you do get how do I derive that. Okay, now similarly, if I talk of the 2 color combination, how many more 2 color combination can you get? You see that C is missing from here. Okay, so C you can choose to do. Okay, so since C is missing, you can place C at the extremes always, and you can have a B, and you can also have an A. Okay, what else can you have? See, B is in the middle, so B you can choose to place at the extremes. A you cannot choose to place on the extremes, right? And in the middle, can you place A? Can you place A? So if you try to place an A in the middle, so you will get something, and if you try to place a C in the middle, then also that is a possible case. I guess I did some mistake over here. Can you guys point out what is the mistake which I'm doing? Yes, you are absolutely correct. You see, A B A you cannot place C B C, because this B and this B will have the same in the same vertical direction. You will have two same colors. So this is the thing which I wrote wrong over here. Okay, and yeah, remaining are correct. So yeah, I can just rub that. I hope you do get it. And these three combinations you get for 2 color. Okay, so you see, what is all of our observation from here? Okay, our observation is that at first, let's consider a pair. That pair, the first element of that pair, give me how many 3 color combinations are present in the ith row. Okay, so in the first row, you know that there are 6 3 color combination and 6 2 color combination. That I had already explained you, right? Six ways and 6 ways. So 3 color and 2 color, there are 6 ways. Okay, and from this you can derive the next ones. Okay, you can derive the next ones. So if this is for first row, for the second row, can you tell me? See, this is a 3 color, this is a 2 color. Each 3 color, gives you two color and 3 color. So each 3 color gives you, so there are total 6 3 colors, right? So if each gives you something like 2 into 6 and 2 color also, 2 color also. Okay, and for every 2 color you get 1 3 color combination, 2 3 color combination, and 3 2 color combination. Okay, 3 2 color combination. So this is this is again the 3 color combination, and this is again the 2 color combination. Okay, so from I minus 1, from I minus 1 row you can calculate these, and from again uh, I plus 1 you can calculate from I, and so on you can keep. Okay, so I hope the approach is very much clear to you right now, and we can do it, we can code it very simply. Okay, so let's see. Let's try to code this out. You can try to solve it on your own also. If you are confident that hey, I have understood everything till now, then you are free to pause the video or even stop the video and solve it on your own. It will help you improve. Okay, yeah. So yeah, I don't mind you if you don't watch the full video. My objective is to make you understand the whole thing. So yeah, dp of n cross 2 I just created. Why? Because I want to store a vector of pairs. Okay, and every pair will give me an ordered set of three color comma 2 color. Okay, so what can I tell? I can keep this as long, and also I want to have a modulo which will be nothing but 29 plus 7. I will use it every time. And what else? I have the initial rows which is fixed with me. So what is this? The first element is giving me a 3 color. Okay, second element is giving me a 2 color. Okay, so yeah, for the first row, for n equals to 0, okay, uh, this 3 color combination is nothing but 6, and again for n equals to 0, this 2 color combination is nothing but 6. Okay, and now we can derive all of them. So for I equals to 1, I less than n, I plus plus, I can choose to derive all of them from the my previous values. So dpi for the ith, this is the 2 color combination. Okay, so this is the 2 color, yeah, this is the 2 color combination, and dp of I1, this is the 3 color combination. Okay, so yeah, from the previous you see, what did I tell? How many 3 color you get? 2 into this and 2 into this. So for 2 color you see, okay, sorry, so the first one is the 3 color which I told, right? First one is 3, second one is 2. Okay, so for 3 color you see 2 into the previous one and 2 into the both of the previous one. Okay, so dp I minus 1 of 0 multiplied by 2 plus dp I minus 1 0 multiplied by 2. Okay, so yeah, I multiplied by 2 for both of them, right, here also, and I'm going to do the same thing, just multiply by 3 for the next one. So this will be a multiplication by 3. Okay, because this is giving me 3 into 6, a 2 color gives me 3 2 color combinations. Okay, so a 2 color will give me a 3 2 color combinations. So yeah, of course this will be 1 and 1. Okay, so yeah, just doing this will not suffice because you need to perform this modulo also. So just quickly do that. I hope I do not have to explain you over here that how exactly you need to perform the modulo. So yeah, okay, so this whole modulo we are having with you, and you can just copy this and have a 3 over here, right? Yeah, you will get dp both of them, and just what you need to return, it's very simple. N minus 1 0. See, what if n equals to 1, what was the answer? 6 plus 6 12 is the answer, right? So both of them, so yeah, both of them you just need to add and return. Okay, so I hope that is clear. So n minus 1 1. Okay, so yeah, let's see if this works. I hope you do get it right, how we are deriving the I minus ith cell row from the I minus 1 row. Okay, so yeah, initialize of vector long no matching constructor. You see, you have to make this long I think, and is this what they are asking for? Let's see. Yes, we are doing a wrong answer over here because we are just adding it here without performing the modulo, which we need to do anyways. So let's see now. Yeah, we do get the accepted thing. If you try to submit, you will still get the accepted thing. Can you optimize it further? Okay, so if you see, for the ith cell, for the calculation of the ith dp, I only need the I minus 1. I do not need the I minus 2, I minus 3 and so on. So it is pointless to use this whole dp over here. Okay, it is actually pointless to use this whole dp over here. Instead, I can just have two variables. Okay, I can call it color3. Okay, and I can call it color2. Okay, and all of this I can just simply replace it, right? So uh, just choose to replace all of this color3, and you have, for this you have color2. Okay, so first one is color3, second one is color2. uh, uh did I remove a multiplication over also? Yeah, so yeah, I did remove the multiplication by 2 and 2 also, so let me put that back. uh, so yes, you have it, and you won't be replacing this, so just have it in a different form. Call it new color3. Okay, call it new color3, and yeah, just have it. And again you can just call this new color2. Okay, so after this, what you can do, you can change this color3 and color2, right? Color3 should be changed to new color3. You're just updating those values, right? Without overwriting. You're just updating without overwriting. Just save into new variables and just update this. So new color2. Okay, and at the end you can simply return color2 plus color3. Okay, so I hope that will be very clear, and it's very simple and easy to do. So let's try to run and check if it works. So yes, we have an extra bracket over here, and yeah, we have the accepted. Let's try to submit for all test cases and see if anything improved. Without using the DP, you see you get 100% runtime bits, and the memory is also quite decent. I hope you do get why this happens and how we are able to optimize it, because for DP I only need the DPI -1. Okay, I do not need it before that. So I only basically need two extra variables. So for the two extra variables, why I will store a uh, whole matrix. Okay, so yeah, that's the optimization. Yeah, and I guess this is a standard optimization also, while you want to compress a 2D array DP into a 1D array or a 1D array into a constant time. Yeah, that's all for this video, I guess. If you have any doubt, definitely ask me in the comment section. Yeah, I hope you did understand the this solution. uh, I will meet you in the next video. Till then, thanks a lot.